Now we're going to calculate second moment of inertia and section modulus around y-axis and z-axis for this profile here. The formula for calculating the neutral axis is shown here on this equation, on this picture in here. We're going to be using from this picture, we're going to be using this information in here. This equation, it is not in your list of formulas, but if you want, you can write this to your formula list for the exam of this course. After we have defined the location of the neutral axis for this profile, after that we can finally calculate the second moment of inertia for the profile using this equation in here. So here I have drawn this profile with some of the basic dimensions shown in here. First step, when we want to calculate the second moment of inertia and section modulus, is to calculate the location of y and z axis on this profile. And the process of doing that requires that we first need to define the additional y-axis and z-axis for the profile. In this case, where I'm gonna place is, I'm gonna place the origin in the top left corner in here. That is where I like to put it most of the times. Then the additional axis will be placed in here, in this direction. Like this. So this is our additional y-axis. And let's do also the additional z-axis. Z additional, like that. Here we have the additional axis. The next step in this process is to divide your cross section to those so-called basic shapes. In this example, the good basic shapes are going to be rectangles. You can divide it in a way you wish, but I will be dividing it to this kind of basic shapes. So firstly, I'm gonna draw an auxiliary line through here. This area here will be my area 1. Then I'm gonna do a second auxiliary line through here. And this area will be my area 2. And finally, the last area down here, this will be area number 3. The next good thing to do, beneficial step to do, is to draw here the location of centroids or center of mass of these areas. Well, because we divided this this cross section into these rectangles, it's very easy to see where the location of these center axis will be. For area 1, it will be in here. Area 2, it will be in here. And area 3, it will be in here, like so. Now I also like to draw here. The estimated location of the y-axis. By looking at this picture or this cross section, I could estimate that the y-axis is probably going to be located somewhere in here. So this is where our y-axis is probably gonna be, roughly. And now what we're trying to solve is the distance from here to here. Z0. Alright, so let's start to calculate the Z0 then. The equation for calculating Z0 is shown up here. So that is the equation which we're going to use. And let's start to calculate that one. So Z0 equals 2. First, we start from area number 1. So the area number 1 is 100 millimeters wide and 25 millimeters tall. So the area of area 1 is 100 millimeters times 25 millimeters. Then we have to multiply that with value Z1. And what is now Z1? Z1 is the distance from the neutral axis or the centroid of area 1 to the additional axis y additional. This one here is Z1, and in this case the distance will be 25 divided by 2, which is 12.5. 12.5. Okay. Then we add here the terms for area 2. This is now area 2. And the width of area 2 is 20 millimeters. So 20 millimeters. And this dimension here is 85. So 20 times 85 is the area of this area 2, and then we multiply it by the distance Z2, which is distance from here to here. And Z2 is 25 plus half of 85, which is 42.5, and that will make 67.5. And then finally we do the same thing for area number 3. The width is 35. The height is 25 times the distance from the center point of area 3 to top surface there. And this will be 122.5. Like that. And now what we need to do is to divide the entire term with total area of this cross section. Total area is 100 times 25 plus 20 times 85 plus 35 times 25. And the result will be 49.9 millimeters. Like so. So now we have located where the y-axis of this profile is located. Well, when we want to calculate the second moment of inertia around the z-axis, we have to do the exactly same thing around the z-axis to find the location of the actual z-axis of this profile. The z-axis of this profile will be somewhere in there. Let's try to make that better looking. One more try. Like so. And this is gonna be the z-axis of this profile. I will not calculate it open here, but with this information you should be capable of calculating it yourselves. And the value for the y0, so this is now, so distance from additional z-axis to the actual z-axis, this distance is called y0, and the answer for y0 is 53.8 millimeters, like so. Okay, so now we have calculated that one. Then, after we have calculated the location of the neutral axis of this entire profile, we can finally proceed to calculating the second moment of inertia for this profile. Let's start with the second moment of inertia around the y-axis. So, I, y. And this equals 2. So, if we take a look at this equation, let's bring it down here. So this is our equation for second moment of inertia around y-axis for a profile. And how it goes is that we first take the second moment of inertia of area 1 around its own neutral axis, which is 100 millimeters, which is the width of that profile, times 25 power to 3 divided by 12 plus, so this here is now this part of the equation. And then we have to add there area multiplied by d, which I will explain in a moment. So the area of this area number 1 is 100 millimeters times 25 millimeters. And then we have to multiply this by d. And the d is now distance from the neutral axis of area 1 to the neutral axis of the entire profile. So this one is d1. And d1 in this case is z0 minus 12.5, which will be 37.4. And this power to 2. And now that was for the area 1, and now we have to sum the same thing for all these areas which we have created on this profile. So that was for area 1, and now we add there the same terms for area 2. Area 2 width is 20 millimeters, so 20. Height is 85 power to 3 divided by 12. So that is the second moment of inertia for area 2 around its own axis. And now we have to add there the Steiner term, because this area number 2's own neutral axis, it is not located at the neutral axis of the entire profile, so therefore we have to include there the Steiner term. And for this one, it is the area, which was 20 times 85, multiplied by the distance from the neutral axis of this one to the neutral axis of the entire profile. In this case, it will be like so, d2, and d2 will be 17.6. And this one power to 2, like that. And finally, we do the same thing for area number 3. The height is 25, width is 35, height is 25 divided by 12. So this is the second moment of inertia for area number 3 around its own axis. And then because that is the neutral axis of that area, is not located at the neutral axis of the entire profile, so it means we must add the Steiner term, which is the area multiplied by the distance from the neutral axis of this area to the neutral axis of the entire profile, D3. And D3 in this case, it is 72.6. And that power to 2. And now when we calculate what this is, the result will be, for this entire thing, the result will be 983.5 10 to power 4 millimeters power to 4. So that's how you calculate a second moment of inertia for a profile like this one. Now it's really important to understand what does the standard term mean. So if you're not familiar with this one, you can Google parallel axis theorem, or you can watch the video about the parallel axis theorem, and that will explain you what this means. Now, around the z-axis, we would calculate exactly the same thing, but instead of calculating the second moment of inertias for the areas, the individual areas around the y-axis, we would have to calculate those around the z-axis. Let's do that. Let's do the example for area 1 just to show you how it goes, and then you can try to do it yourself for the rest. So the area 1, the second moment of inertia of area 1 around z-axis will be 25 times 100 power to 3 divided by 12. So now you understand that 100 is now the height, because we're rotating it around z-axis, not around y, but z. And then we have to add there the standard term, which is the area, times the distance of the center point here through the neutral axis of this entire profile, which in this case will be 53.8 minus 50, which will be 3.8. So 3.8 power to 2. And then we would do the same thing for other areas. Area 2 plus area 3. And the result you should get is IZ is 233.2 10 to power 4 millimeters power to 4. Like that. And finally, if we want to calculate the WY, section modulus around Y, so that is I around Y divided by the maximum distance, and in this direction the maximum distance will be the total length of the profile, which is 135 minus 49.9, and that will mean it is 85.1, which equals to 115.6 10 to power 3 millimeters power to 3, and the W around Z is IZ divided by 53.8, which is the maximum distance to the edge of the profile in horizontal direction, and this one equals to 43.3 10 to power 3 millimeters power to 3. So here we have an example how we can calculate the section modulus and second moment of inertia for profiles that can be divided into these basic shapes.